Hello student, let us enter into the one more session of our mathematics, and that session is for chapter 4 determinants. So as per our schedule, always we revise the previous topic. So in this also, first of all we are going to revise previous topic, and previous topic was, when I started this chapter, after a meaning and definition of a determinant, I told you how to expand determinant of order 2 and 3. Already we did some questions of exercise 4.1. The exercise 4.1 is very easy, but then also there is one very important question which I did on the board, and one I gave you as a homework. Hope that you did that homework. So first of all, in a previous session we did determinant, its meaning, its definition, difference between the determinant and a matrices, and how to expand determinant of order 2 and order 3. Now today's session is very important. Usually I call this particular article as a core of this chapter. Why? I am giving you surety that one question surely you are going to get on this topic. So we'll see what this new topic is. So it's an article 4.3. Be careful, and some properties of a determinant is given in under this article 4.3. So I'm going to read out that sentences. The proofs are also given in a book, but in exam they are not asking that proof. Proof is just to support these properties. So one by one I am going to read out that sentences. You also go through the textbook and go through that proof. Proofs are very easy, but proofs they are not asking in exam, but properties are very important. These properties will be used in a coming exercise to solve some important question. And again I am telling you, one or two questions surely they are going to ask in any coming exam. So first of all, one by one I am reading out this properties of a determinant. You also keep the textbook in front of you and just go through that properties. Proof then just for a practice you can do it by yourself. Now property number 1, what is that statement? Property number 1 says that the value of determinant remains same or identical. The value of determinant remains same, identical or unchanged if rows and columns are interchanged. What does it mean? If you are given any determinant and you find its value, it's given in your book also as a proof. If suppose any determinant is given and you expand it and you find its value, then interchange the rows with a column, then again you expand it. So answer of both ways is going to be same. Who says this? It's a property number 1. The value of determinant remains unchanged or a constant or identical or a same when you interchange the rows and a column. Do you remember I told you how to write this in a symbolical form? So as a note it is given in your book. If you want to show that rows are interchanged with the columns, so one symbol is used earlier in the previous chapter in matrices. I told you about that symbol. Ri interchange with Ci. What does it mean? Ith row of any determinant is interchanged with the ith column of that particular determinant. So what is property number 1? Where we are going to use this property? Wait for one more day or one more session. In the next session I will be telling you how to use these all properties. So property number 1 says, whenever for any necessity, if you are interchanging the rows and the columns, corresponding rows with the corresponding columns, there is not going to be any change in the value of determinant. This is property number 1. Now what is property number 2? If any two rows or any two columns, see the bracket, if any two rows or any two columns are interchanged, then you find the value of a given determinant. First of all, you do one thing. Take one determinant, take its element, expand it, you will get the single values. Then you interchange the rows with the rows, any two rows, row 1 with a row 2 or row 2 with a row 3 or any two columns, and then again you expand, then the value of a determinant will differ by minus sign. What does it mean? Whenever any two rows or any two columns are interchanged, then value of determinant change by, or value of determinant is having a different sign, means positive value will have a negative sign or negative values will have a positive sign. Symbolically, as I told you in the matrices, it can be written in this way: ith row is interchanged with the jth row, and ith column is interchanged with the jth column. This is the way how you can represent. No need of writing complete property during the solution of a question. During the solution of question, rather writing this complete sentence, you simply write this symbols. It means that property number 2 is. So twice I am repeating now. What is property number 2? Whenever any two rows or any two columns are interchanged, then the value of determinant sign is going to change. Minus sign will come if earlier the value of a determinant was plus. Okay, it's a property number 2. Now there are many questions on a property number 3. There are many questions in a property number 3. It's like an ideal property for a objective type question. Now what is this property 3? Whenever any two rows or columns of any given determinant got a same or identical element, if any two rows or any two columns have a same elements, then don't expand that determinant. Close your eyes and write the value of that determinant 0. What is that statement printed in your textbook? Property number 3, if any two rows or columns of determinants are identical, what does it mean? Their elements are same, then the value of determinant is 0. Don't expand such determinant, because then you are wasting your time. Directly you can write answer as 0. One example I took. Suppose A is equal to, any determinant is given, A is equal to 3 4 3 1 2 5 3 4 3. You know how to expand this determinant. You can find the value of determinant, but no need of doing so. According to this property number 3, the value of determinant will become 0. Now one more property is property number 4. Now what is that property number 4? If each element of rows or columns of determinant is multiplied by any non-zero value of k, any k means any constant k, but non-zero constant k. Suppose k is 0, then whole determinant will become 0. But property 4 says that if each element of any rows or a column is multiplied by constant k, you will surprised to know then the value of that determinant will be multiplied with k. Here k should be a non-zero constant, otherwise automatically value of determinant will become 0. So fourth property is also very easy. One example I am telling you. Suppose A is any determinant, A1, A2, A3, B1, B2, B3, C1, C2, C3 are the members of this determinant. Suppose if you are expanding directly, and suppose its answer is equal to simply del, the value of that determinant is del. Now suppose if anybody is asking you to multiply all the element of first row by constant k, so what will be the new determinant? K1, K2, K3, rest of the members will be identical. Now again expand. Earlier you expanded this value, now you expand this values, then difference in the answer will be, final answer will be k times of a initial one. So this is property number 4. After completing property 4, last two properties are very important. Up to 4 properties, while understanding or while using also, it was slightly simple. But property number 5 and 6 are very important. Most of the question of a coming exercise depends on these two properties. So we are going to understand properly. First of all, what is the statement of property 5? If you remember statement of property 5, it will be very difficult for you to remember. They are not going to ask you to write this property 5. It's not a theoretical part. In some book, it is given in the form of theorems also. Theorem 1, Theorem 2, Theorem 3, Theorem 4, Theorem 5, Theorem 6. But in our book it is given like a properties with the proof. But in exam they will not even ask that statement. You should know how to use that statement. So if I am going to read that statement, you will be confused. So try to understand with the simultaneously with the example also. But before that, let me read out the sentence which is given in your textbook also. If some or all elements of row or column of determinants are in the expressed as a sum of two or more terms. If elements of a determinants are expressed in the form of some or more terms, then you can express that big determinant in the form of a two small determinant. That added terms can be written separately as one of the row of that new determinant. Again, I am reading out that property 5, but they are not going to ask that statement. But you should know the idea about that statement. If some or all elements of a row or column of determinants are expressed as a sum of two or more terms, then determinant can be expressed as a sum of two or more determinants. Now, one nice example is given in your textbook. There is one determinant in which you see first row is in the form of sum of two elements, a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, and other two rows are simple one, b1, b2, b3 and c1, c2, c3. Now, with the help of this property, how you can change? This step is important. If you try to solve this, it will take a lot of time. While expanding also, it will take a lot of time. But when you convert it into a two determinant, so first determinant will have a first element of this one or first term of this particular determinant, the earlier one, a1, a2, a3, then b1, b2, b3, c1, c2, c3, and then second determinant will have a second term. So this property is very important. Now second determinant will be in between plus sign. Suppose if we have a minus sign here, so we will have to write minus in between. Then lambda 1, lambda 2, lambda 3, and rest of the members are going to be same. So this property will be very useful to you when any determinant will be expressed in the form of sum of the terms. Not only two, in some determinant there can be that we are going to get a three terms at the as a first row. You may get a three terms. How? a1 plus lambda 1 plus lambda 2, a2 plus lambda 2, and then one more term. Then you can express it into a three determinant also. So this property is very important. If you can remember, then remember that statement, but how to use that statement, that is important. Most important property is property number 6. Usually I tell the student, all 4-5 properties you remember, but most of the questions will be solved with the help of property number 6. So again, statement is slightly complicated, but I am reading out that statement and then I will tell you how to utilize it. Again, I am telling you in a coming exercise, most of the question can be solved with the help of this particular properties. So if to each element of any rows or columns of determinant, the equimultiple of corresponding elements of any other row or columns are added, surprisingly there will be no change in the value of the determinant. The value of determinant remains unchanged. Slightly complicated statement. If you are multiplying with any constant with any rows or columns of that determinant, and then you add with the other rows and columns, and when you expand it, surprising the value of determinant will remain same as the earlier determinant. When to use, how to use these properties, I am going to tell you in a coming exercise. But before that, you can express this with the help of symbols also. This is very important. While solving the question, you will be able to solve that question, but side by you will have to write these properties. From where we got this property, symbol actually, property already I told you, symbolically. From where we got this symbol I told you during the matrices also. Suppose any row R1, if you want to replace it by some multiple of some other row, for example second row. How we are going to write? R1 will be written as in the form of R1 plus k times of R2. Not always positive. Sometime if you require, then you can write minus sign also. Here k is non-zero constant. Remember, k is non-zero constant. This is important property. Suppose if you don't want to operate that row and if you want to operate in the columns. So if you multiply with the constant with any column and add with the given column, then expand that determinant, surprisingly the value of determinant remains unchanged. So this last property is very important. Where to use, how to use these all 5 or 6 properties, that I will be telling you in a coming exercise. So coming exercise is very important, exercise 4.2. I am telling you, surely you will get a 3 marks question and 1 or 2 questions in a objective type. Come on, let us revise all the properties one by one. Property 1, if you are interchanging the rows and columns of any given determinant, property 1, then there will be no change in the value of determinant. But property number 2 says that if any 2 corresponding rows or any 2 corresponding columns are going to be interchanged, then there will be difference in the value of determinant. Value of determinant will have a opposite sign. Whatever the sign was for earlier determinant, the value of a new determinant will have a opposite sign. So this is property number 2. Property number 3 says that if any 2 rows or columns got an identical element, then the value of determinant will be 0. That also I told you. Property number 4, 5, 6, you remember, most of the question will be solved with 4, 5, 6. What is property number 4? If you are going to multiply any element of any rows or columns with a k, automatically the value of determinant will be multiplied with a k. That is property number 4. 5 is still here. What 5 says that? 5 says that if any rows or columns elements are in the form of a sum, you can express in the form of a sum of a 2 determinant, as I told you with the help of example. Then last property is you can replace any rows or columns by adding that rows elements with the some multiple of a corresponding rows or columns of that particular determinant. Surprisingly, the value of determinant is not going to be changed. It is already proof is given in your book, you can go through it, but theoretical part proof they are avoiding in a exam. Now I have chosen one question from exercise 4.2. There are many questions. Gradually in a coming session I am going to solve many questions. I am going to solve because this exercise is very important. Now one question, question number 4, I am going to solve as a 1 marks question. It can be asked, but remember, each and every question can be solved with a many method. It is not necessary that you solve with the method which I am doing it. It is one of the method because we got a many properties now. You can utilize any properties properly. You can solve that question with a many methods. In a practice, you will see that the question 4 which I am going to explain can be done with the some other method also. One of the method which I am suggesting you, just see on the board. Suppose question is given. Question is any determinant is given and the members are 1, 1, 1, BC, AC, AB, A, B plus C, B, C plus A, C, A plus B, and question is question number 4, exercise 4.2, and they are asking you to prove it equal to 0. So first step is, I started with the left hand side. First step is don't touch column 1, leave it as it is. Column 2 also leave it as it is. But in a column 3, use distributive property. So this element will be like this: AB plus AC, BC plus AB, AC plus BC. What I did, I used the distributive properties. Now this is your step 1. Now second step is, since I saw that I am supposed to prove it equal to 0. So what I will do, I will try to make 2 rows or elements of 2 rows or columns identical. So see the important step. That important step is column 3 is replaced by this. You will have to write, otherwise half marks will be deducted. If you are doing it directly, you will not get complete marks in a theoretical questions. So column 3 is replaced by column 3 plus column 2. I am adding this column 2 with column 3. This you will have to write. So what new determinant becomes? New determinant will be like this. Don't touch column 1. Don't touch column 2. But how I wrote? Column 3. So operation will be with column 3. So our column 3 will become, add these elements with column 3. So it will be AB, AC, BC in the addition form, because it's a property number 6. Even here you can write using property number 6 also. It's up to you. Then new determinant or new step of determinant will be 1, 1, 1, BC, AC, AB. AB plus AC means I am adding this column with this column. So what you will find is all the elements of this column is same. So I am using one more properties, property number 4. You know that we can take out common from any rows or column. So I am taking out this as a constant outside, AB plus AC plus BC, because it is constant throughout this column. So now my new determinant is 1, 1, 1, BC, AC, AB, 1, 1, 1. And again third property, two columns are identical, no need of expanding it, you write it equal to 0. This is one of the suggested method. You can do it with the many other method also. This is one of the suggested. Here I use 3 properties. So how to use this property is very important. In coming session, I am going to do many such questions where these all properties are going to be used. Now your homework is just go through the statement of each and every properties and see the examples also in your textbook. Then we will solve some more questions of exercise 4.2.